The second type of inversion for our purposes is an upper level inversion. This occurs above the surface of the planet, as the name indicates. These are very common in Southern California. The conditions are ripe in Southern California to create upper level inversions. And in fact, in Southern California, we are frequently under the influence of upper level inversions. What happens is very, very cold air from a loft descends. A loft means way up in the atmosphere, 20, 30, 40,000 feet up. Keep this principle in mind. Warm air rises, cold air subsides. That very cold air that's descending, that very cold air, as it's coming down, is slowly warming up. You've probably been in an airplane and flipped on the screen to see where you were. And in addition to the map showing you where you are, it tells you that at 35,000 feet, the temperature is minus 65 degrees. So if the air temperature starts out at minus 65 and is descending over Southern California, when it gets close to the ground, it's obviously not minus 65. What's happening? The air is slowly warming up en route to the ground. What it then does is that slowly warming air settles on top of cool surface air. In the case of Southern California, this comes in off the ocean, as you'll see. Take a look at this diagram. First, start on the left-hand side. You can see that at the top of the diagram on the left-hand side, it says subsiding air. In other words, you have cold air that's coming down towards the surface of the planet. En route, in the middle of the diagram, you can see that the air warms up. Then down at the bottom, you can see trapped cool air. Whether that trapped cool air is there because it blew in off of a cool ocean, or whether that trapped cool air is there because it subsided down a mountain, or whether it's there, like I mentioned before with low-level inversions, because it was a long, cold, clear, calm night and the ground got cold, causing the air in contact to be cold. Whatever the reason is, we don't know with this diagram, but there's cool air along the surface. As the subsiding air comes down and it warms, at some point what happens is that subsiding, warming air is actually warmer than that cool surface air. Remember what I just told you? Warm air wants to rise, cold air wants to subside. However, that warm air can't rise because there's air above it shoving it downwards. And it can't go down any closer to the ground because there's cool air there, and it does not want to go down below cool air. Warm air doesn't want to do that. This is what sets up the inversion layer when you have an upper level inversion. If we look at the right-hand side, you can see that red line that I've drawn. That red line indicates normal conditions in the troposphere. Increasing altitude results in decreasing temperature. As you look to the left along the scale on the bottom, you can see the temperatures are going down. As the red line goes to the left, it's indicating that temperatures are going down as you're increasing altitude. Well, if you take a look at the blue line at first as you leave the ground, it is indeed indicating that temperatures are going down. However, what happens if you compare it to the diagram on the left-hand side, right about the place where the inversion layer is shown on the left-hand side, right there, air temperature actually begins to increase with increasing altitude. When the blue line heads off to the right-hand side, that means increasing temperature. And you can see that what's happening is, as the line's getting higher in the sky, the blue line is also heading to the right, meaning increasing temperature. That is the upper level inversion. But then you can see, you look at further up, and what happens? It goes back to its normal conditions of decreasing air temperature with increasing altitude. I drew a diagram of Southern California for you. If you take a look at this diagram, you can see mountains, Los Angeles Basin, cool ocean. Those are supposed to be Los Angeles, downtown Los Angeles. Anybody who knows Los Angeles knows the city does not sit right on the ocean. It's a little bit inland in this big flat basin that is the Los Angeles Basin. You can see the mountains. The mountains in Southern California are to the north and to the east. And then you can see cool ocean. The ocean is to the west and to the south of Southern California. Basically, on a daily basis, what will happen is this. Cool air from the ocean blows in and fills the LA basin. Now, that air as it comes in is not blowing strong enough to get up over the tops of the mountains in Southern California, which have peaks over 10,000 feet in some places. But it does come in and fill the Los Angeles basin with relatively cool, moist marine air off of the ocean. At the same time, in Southern California, we live most days of the year under high pressure. You don't need to know a lot about high pressure yet. We'll get that in the next section. Basically, what happens with high pressure is the air descends down towards the earth. It subsides. In the case of Southern California, the primary reason is because tens of thousands of feet above us, the air is very cold. Cold air wants to subside, warm air wants to rise. So very far above Southern California, there's very cold descending air. That's what sets up the high pressure. That high pressure is also the thing that gives Southern California its quintessential blue skies. It's the reason in Southern California we live most days of the year under blue skies. It's because we sit under high pressure most days. But as that air is coming down, it's warming up en route to the ground. Now, in Southern California, right about 2,000 feet, where you see that bronze-colored line, right about 2,000 feet, something happens. And what happens is this. The air that's descending and warming is actually slightly warmer than the air that's just below it that blew in off the ocean, which I have indicated with 57 degrees down below, 58 degrees above. That's the inversion. Remember, what should be happening is as you increase altitude, air temperature should be decreasing. But if you look there, as you increase altitude, air temperature increases. In Southern California, that's usually right about 2,000 feet, but it varies from place to place. In Denver, in Mexico City, in Houston, they're going to get it in different places than we do in Southern California. But in Southern California, this is typically about where the upper level inversion sets up, which means that if you were along the surface of the ground and it was 62 degrees, as you went up, here's what would happen. It would be 62, then 61, then 60, then 59, then 58, then 57, then 58. That's the inversion. As you go up, air temperature should be decreasing, not increasing. And then what we do in Southern California is we turn on our cars, we turn on our factories, we turn on the port, we have a barbecue, and Los Angeles disappears under smog. That smog cannot get out because the inversion layer is holding it in. It won't be able to rise because you can see all of that air pressing down on it. Plus, you have cold air below, warm air above. Cold air does not want to rise above warm air. Furthermore, because the air blows in off the ocean, the smog won't blow out to the ocean. Additionally, because the mountains are relatively high, the air can't get over the top of the mountains. The result is Southern California disappears into smog. Here's Southern California. If you look carefully, you can see the smog. That is where the inversion layer is at.